Okay, so in this video we're gonna look at higher order functions. So what is higher order functions? Higher order functions are functions that take other functions as parameters and return a function, such as repeat. So let's go to our code editor and see how a higher order function looks like. I'm not really good with naming functions. Anyway, so here we have a function. So to make this higher order function, we need to, like, let's say function. Okay. Okay. So this is a higher order functions because we know that because it accepts a function as a parameter. So the parameter name is fucked. I don't know, dude. Function. Let's say that. Okay. So we're not really like creating functions. We are we're gonna look at some higher order functions that the Kotlin provides us. So knowing these functions gonna help us perform common tasks such as sorting and filtering. We're gonna look at that. We have like six of these higher order functions we need to know in order to make really good Kotlin programs. So for each, let's start with for each. But before that, we're gonna look at the template. Okay, so we have a class and a constructor. Inside of this constructor, we have 4 variables: name, soft baked cookies, f as filling prices. So we're creating a list of these objects, cookie objects. We can also, if we want it, pass in the cookie type. So normally you would probably see using classes as a type. So we have a list of cookie essentially. So we are passing different values. So every instance of cookie is different. So this instance is different from this instances because all the properties are different. Also these instances are stored in different locations in memory. Okay, so let's try using the for. We have a list. So most of these higher order functions are used on collections. So this is a list collection called cookies, and let's with for each, expecting a top level declaration. Okay. So this is a higher order function. This is just a function. So the every cookies, every list has all these higher what do we mean by that? Every lists have these built-in methods: for each, map, filter, group by, fold, sorted by. We're gonna look at each eventually, but for now let's look at the for each. So to make for each higher order function, if we know that for each is a higher order function, so it accepts another function. So if you look at the signature for this function, it's like this. So it accepts a action that's some type and returns doesn't return anything. Since it's the only parameter, we can use trailing lambda syntax. And the only thing that's gonna be passed to this lambda expression is this. So the elements. So if it was a string, it's passed a string. If it's an object, it will be passed. It passes an object. We could call it anything. For example, we could call it object and start working with it. So we have our object and name. Why are we getting this? Name expected. That's a keyword. Okay, so let's see what happens. Yeah. Print name. We got the names. So they are creating this. Let's try to create that. They use that so that we to introduce templates. We're gonna look at what templates are. So in order to insert embed a variable, we use this $sign and this. So name is a string, right? So look at what we got. We got this I don't know, this is just a reference to the object, I think, and we got this. So this is not how we are supposed to use this when we try to embed some value you access from an object. So if you try embedding like this, you would get this. Instead, we use this curly braces. Okay, let's try. Let me show you something really quick, interesting. Something. Let's say I have a name. Call it print ln $sign and name. Whatever, bro. So we we embedded the string inside of the string. So what I'm trying to tell you is that you can use this all the time. It's up to you. So if you use the if you use it all the time, you would never need to know if some access methods can evaluate to string or not. let's see what does it return. Result. Okay, for each runs this and returns. It doesn't return anything. So what are they doing here? So instead of for each, you get the object, right? You get the object, every object, one at a time. Now you can perform any action on each of the objects. For example, you can print the name, or you can calculate something on the object. So essentially, if you wanted to perform a task on every object in a list, every data type in a list, you use for each, but it does not return anything. So it does not return a modified list. For that, we use map. Okay, so what does map function do? It lets you transform a collection into a new collection with the same number of elements. So if we have a size of, let's say, what's the size of this? 7. Map functions will always return a collection with the same number of size when you started with. So you have an integer, you transformed that integer into strings, right? Let's do that. Let's create. Let's create a list of integers. Let's say integers. A list of 1, 2, 3, 4, 5. Okay, now we can use the map on this collection. Just like for each, we get each element inside of the collections to the as a parameter inside of the lambda expression. So we could either use it as a it, we can reference it as a it because it's the only thing that's inside of the parameter, or we could name it. Last time I named it, so let's print the it. So we get 1, 2, 3, 4. So so to really transform it, we need to return something to string. Let's do that, and let's say strings So when we print the array, we got an array of this. Even though it's string, it does look like integers. So how do we know if it's really string? Let's try getting get one. Is there a way to is there a way we can check if some data type is actually that data type? I'll be back. Okay, seems like we can use is to check if it's a string. Check, for instance, is a okay, so we get true. Let's say we pass in integer compatible. Why say we got an error? Incompatible types, string and int. Oh, why? Two is always false. What about int? So if it's not a if it doesn't evaluate to true, we actually get an error. That's inconvenient. We don't want errors. Anyway, that's how we check if it's a string or integer. We use the is keyword and passing in some operands. So essentially, map transforms the input to some way, like you specify how you want to transform the inputs, and the map transforms it. So we have a list of chocolate chip or whatever, some garbages. So we're gonna create a list of names. Let's get over it. So they call it full menu, right? We're gonna use the cookies and map. We're gonna just return the names. So name, full menu, and for each doesn't return anything, but we can perform a task on the list. So I want to print the names of the elements. So I'm gonna tell it to print everything. Or let's say print ln and full menu. So as you can see, it returns a array, transformed array. The size it has the same size, but it's been transformed. So we add a name, soft baked, as fillings, and all this. So it returned an array. So what if we wanted to return array with name and soft baked? Okay, that's a good question. Let's say it name, maybe it dot price. Why we get unsupported collection that outside of annotations. Replace with RAF. Whoa. Type mismap. Required integer found string. Let's give it a type. Type of, it's a list with name, which is a string, price, what do we start? A double. Okay. I honestly thought this would work. If it was JavaScript, it would have probably worked. I'm gonna be back. So if you wanted to so the list only contains one type of data type, so I'm passing in two. It can't hold two types of data types. All the elements in a list is one data type. It's gonna be either a list of strings or it's gonna be either doubles. There's a built-in class that we can use to pass in a pair of name and price. We could pass like, let's copy this, copy pair, and we can pass this and say that it's a pair of string and double. But if we wanted to set up custom returns, we need to create a class. Let's call it full menu. We need to create a constructor and name, call it a string and price of type double. Now we can replace that with this and pass the it name and it price, and we need to return that full menu. So the list contains elements of full menu, something like that. So this is how we return more than two elements. I mean, not, yeah, so it returns instead of returning one name, it returns a list of name and price. So every element will have name and price. So that's what I'm trying to do. In fact, JavaScript also has a map method. So I'm gonna show you. Okay, so you can open console anywhere. So let's try to clear. Can we? I'll be back. Okay, I want to show you quickly how the map functions in JavaScript work. So we have a array, and we have an object. We have three objects, and since it's an array, we can use the map function. So we're passing an object, and look what we are doing. I like this kind of syntax. We're returning an object. In JavaScript, objects are inside of curly braces. We give the object a key value pair, we use a variable name and a value. I like this syntax. And when we check it, we get like this: object name array of this. So essentially, I believe every programming languages probably have this kind of like methods and arrays. Where is it? And look at this. We have to create a class, and then we need to pass this. Why can't I just since it's a array, why can't I just like, you know, create how we did here? Where is it? Like this. Return object literal. Inside of that, we just pass in what we want. So this is something I need to get used to. Instead of passing in returning object literal, and we need to create a class and return it like this. Anyway, that's how the map works. So we're gonna look at a filter now. A filter, what does filter do? Okay, so if you add a list of numbers, you could use filter to create a new list that only contains numbers divisible by 2. Looks like we... Anyway, so the filter create a subset of a collection. So you can either, if let's say you have a size of, I don't know, 7. You have an array with size of 7. And filter returns usually returns less than what you started with. It could also return the size you begin with, but essentially with filters, right, you're trying to filter out some elements. You're trying to reduce the size of the array. So how would you reduce a array? Well, one way is just passing in some conditionals that checks if something is true. If it's true, you add that to the returned array. If it's false, you take it out. So for example, here we have an array, and our condition is the element, each element we're gonna return elements that are divisible by 2. So 8 is divisible by 2, 6 is same thing, 7 is not, so we take it out, and so on. So returned array meets that condition, divisible by 2. So let's try to do that. We need to create a element, right? And we call it some numbers, and this is a list of numbers. 8, 5, 7, 6, 3, 9, 11. Okay, so these are integers, and let's call it a result. Here we're gonna call the filter method on this collection, and we could use the modulo operator. Do we have that? Type mismatch required boolean found integer. Right, so it returns true. So how are they doing it? Found integer. So this returns 0. If it's divisible by 2, we probably get a, what do we get? So if it's divisible, the modulo operator returns the remainder. So how do we make it a boolean? If it's a whole number, it returns 0. We check it. We divide it by 0. If it is equal to, we divide it by 2. If the remainder is 0, then it's a even number, right? So let's try printing the result. Okay. So essentially, the last expression should be a boolean. So the previously the expression that I wrote returned a integer instead of boolean. Okay. So now we have a string boolean. Okay, so these two already returns a boolean. Let's say we're gonna start with a result and cookies and filter. Since this has since this is already boolean, if it's true, it's gonna be added to the result. If it's false, it's not gonna be added to the result. Let's say result. What do we get? We get these objects. So I want the name. Okay, I want the name of the object instead of this. So how are we gonna do that? Oh, result for each. Can I do that? If I go here and name, let's do print. Okay, we somehow managed to get the name of the objects using by chaining filter and for each. Did you notice something? We are chaining it. We can we use the scoped functions for this? Let's try doing it. I'm gonna use apply. Inside of the apply, I'm gonna filter it as filling, and then for each name. I don't think it's gonna work. So cookies name, nah. Maybe like print. It'll probably work if we use it like this. Why is that? Name. And this name. This is also not working. Why is that? Okay, so I tried creating a code that actually works. So we have a scoped function apply. First we filter it, so the result of filter is this object. Then we print out the name. So this is not what I expected. So we essentially we're not using the returned array. Instead we're using this same instance, which is what apply does. So it returns the same instance for the both functions. So that's kind of obvious. I'm kind of dumb. So instead what we gotta do is we shouldn't use the apply. First we're gonna use the filter, something like what did we use? We used the it as filling. So this returns that, and we can change this for each and now we print it. It name. I have no other code. Let's clean this up real quick. Okay, so this is the only code. If I run it, we should we should get the filter result. So that's how you like kind of chain the higher order functions one after another. This filters it, this for each does something on the filtered list. So let's look at the next thing, group by. I think group by is kind of hard because I'm not used to it. This is something that's in JavaScript, I believe. Okay, so let's look at the group by. The group by function can be used to turn a list into a map. Okay, so a map is just a list of key value pairs. So we have a key to some value. Each unique return value of the function becomes a key in the returned map, and this is important. The returned value becomes the key. The values for each key are the items in the collection that produce that unique return value. So the values are the items in the collection. I believe the value is gonna be a list. So let's look at this. So we have a list of integers, and we have a condition. This is condition. We group by, we pass in some condition. The return value is 0, 1. So this modular operator returns reminders, right? So if it's completely divisible, it returns 0. If it's not divisible, it returns whole numbers. I mean counting numbers, whole numbers, whatever. So it returns a number. So these numbers, becomes key. So if it returns a 0, it becomes a key. 0 becomes key. If it returns 1, it also becomes a key. And it uses that key, and it checks, does this divisible by 2, and it produces 0, and it keeps that as a value, and checks this, it produces 0, and it passes that to the key, so on and so forth. Let's try that. First let's start with the integer example. While numbers list of, Let's try this. Okay, so numbers group by, and we pass in something that returns key. So this returns a key. It divisible by 2. Let's try printing it. Oh, while result. So this is a key value thingy map. We have 1 and 0. These are the keys, and these are the values. These are the elements that returned 1. So boolean. Let's try this. Cookies group by, well, we want to group by soft baked. True. This, since this is a boolean, it's gonna return true or false. Right, so soft baked. Let's call it a result. Keep it simple. Don't wanna think about coming with unique variable names. Print and result. What do we get? So this produces true or false. So these are all the objects that produced false, and so on. Also, let's try, since that returns an object, let's try for each and it name. That's the thing, we need to use the lambda expression, it name. Why? Oh, instead of that we can just use the here. God damn it. Where is this cursor, man? Print. Why is this? What's happening? This returns soft, this returns, okay, this returns a map, so we cannot use for each another map. Okay, that's something to watch out for, I guess. So map so we have a soft baked. Let's print. So how do we access? We access the using get true. That's gonna return array. Now we're gonna use for each on that array and print it name. Okay, so the map always returns some sort of like nullable. God damn it. why, dude, what is this? I'll be back. Okay, so that was weird. This code editor goes into block mode when you press the insert button. So as you can see, the cursor is a little thick. Okay, so you get since this returns a map, you can get the values by passing the key to get, and the map returns are sort of nullable kind of values, so you need to use the safe operator to access it. I didn't use the print. Let me go back. Print its name. Okay, so this banana doodle tart, these are all soft baked cookies essentially. When do you want to use this? I don't know. So you have a soft baked cookies, and you want to group cookies. So by using this group by, you get cookies that are soft and cookies that are not soft, because we used booleans. So there's going to be true and false. True and false keys in the map. True values are cookies that have soft baked. True cookies are soft baked. False cookies are not soft baked. So then we have a fold. A fold function is used to generate a single value from a collection. This is most commonly used for things like calculating total of prices or summing of the elements in a list to find an average. Okay, so if you use a JavaScript, again, this is similar to reduce function. So essentially, this is unlike map and filter. Fold always return one element. Let's try creating it. Again, let's start with integers. List of 1 2 3 4 5 6. Okay, numbers. We're gonna call what's that? Fold. To actually use the fold, we need to know some things. For example, you're gonna pass in the initial value, which is 0, and this is a function. So, how you want to do something like what you want to do with every element in the function. So every element for the fold function, you get two values, right? This passes two values, 1 and 2. First, you're gonna set the initial value, which is let's say 0.0, and here you set a function that accepts two values. Okay, let's create a function that to accept two values and you add them. So this is the returned value. This adds the initial value and the some element from the array. This is called something called running total or something. Every time it adds and the return value becomes the initial value, hit this A, and next it passes 2 for B, and then it adds and it uses the return value for the initial value, which is A, so on. So initial value, we could either mention it, I guess. So we're using 0 as initial value, so it becomes A becomes 0, the B becomes the first element in the list. So let's try printing it. Numbers result. So essentially we added it. We added every integers in the list. This fold is really used for like we said in the beginning, it's really used for calculating total price of something, or summing all the elements in a list, you know, that sort of thing. Okay, so this is the last thing in our higher order functions, sorted by. Sort function could be used to sort the elements, collections of cookie objects. This won't work on a collection of cookie objects. The cookie class has several properties and Kotlin won't know which properties you want to sort by. For these cases, Kotlin provides a sort by function. As you specify a lambda that returns the property you like to sort by. For example, if you like to sort by price, the lambda would return it price. So long as the data type of the value has a natural sort order, strings are sorted alphabetically, numeric values are sorted in ascending order, it will be sorted like a collection of that type. So when you call sort on a list of integers, you get this sorted list in the ascended order. So there's also another method, sorted by. Cookie objects, right? We have a list of cookie objects, like the mention. The sort method doesn't know which methods to sort by. So if you return the property in the lambda expression of the sort by, it sorts that. It returns a list, sorted list, using that property. So that's pretty much it, I guess. Alphabetical menu. Okay, let's try doing that. We have cookies. Let's go cookies. We can use sort because cookies object it doesn't know the Kotlin doesn't know which properties to sort by. So we use sort by, another method. We tell which properties to sort by. It name. So we actually got an error. Then for each cookies, sort by each name. We're using the same thing. Unresolved it. Sorted by typo. Happens to the best of us. Result so we got objects sorted by the price. What about name? Oh, that's no, we're using the name already. Let's try something else for each name. What the hell? Oh, right, we're not using print. Okay, so we got a banana. These are all sorted by the name. So B, B, C, S, S. They're sorted alphabetically. We can also sort by price. Okay. So we looked at all the higher order functions that are available for arrays, lists. These methods are, I believe, usually these are like uniques to lists, arrays. So these methods are not available on classes or objects. That's how it was for JavaScript. I don't know for Kotlin. That's pretty much it for this video.